In this video, we'll be talking about the graph of y equals secant x. Now we know that secant x is the reciprocal of cosine x. So to get our graph, we'll consider the graph of y equal cosine x. Our cosine curve is shown here with the dotted line. Recall that at the y-axis, it has a value of positive 1. And then it reaches a minimum at pi and a maximum at 2 pi and so forth. Well, our secant x is a reciprocal. So the reciprocal, or the secant graph, has asymptotes wherever the cosine graph crosses the axis. So our cosine graph crosses here at pi over 2. And so for our secant curve, we need to draw an asymptote at pi over 2. Also, our cosine curve crosses the axis at 3 pi over 2. So we need to draw an asymptote for our secant curve. Another thing to remember is that the reciprocal of 1 is 1. And the reciprocal of negative 1 is negative 1. So my cosine curve hits positive 1 here at negative 2 pi, and here at 0, and here at 2 pi. Well, my secant curve is also going to hit 1 at those values. Then, if you'll notice, just one thing to remember, as my cosine curve gets smaller and smaller and smaller, in other words, gets closer and closer to 0 right here in this little interval, my reciprocal function, the secant, gets bigger and bigger. So, some information that you need to remember about the secant curve. The domain is the set of all x's such that x is not equal to 2n plus 1 times pi over 2, where n is an element of the set of integers. Remember, this not equal to is where all of our asymptotes occur. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and it's a periodic function as well, so it keeps going on forever and ever in both directions. So to ask ourselves how to write it algebraically, we ask ourselves what stays the same and what changes. So we see that we have our pi over 2 in all of the terms, and so we write that. And then the thing that changes out here, we have a 1, and then 3, and then 5. Those are odd numbers. So the way to guarantee that you have an odd number algebraically is to first write an even number, 2n, and then add 1 to that. So 2n plus 1 is an odd integer. Our range, now our range is a little different from our sine and cosine in that we have negative infinity all the way up to negative 1. We include the negative 1, and then there's a blank space in between here because this, remember, this dotted line, this is your cosine curve. And what we want to talk about is our secant curve. So our range is from negative infinity to negative 1. Include the negative 1 in your interval. Union with 1 to infinity. So the secant curve is discontinuous at x equal 2n plus 1 times pi over 2, where n is this element of the set of integers. There are no x-intercepts because this space in here between -1 and 1 is blank. The period is 2 pi, so the period is the same as the period for cosine. There's no amplitude since it goes on forever. And it's symmetric with respect to the y-axis. So it's an even function. So secant negative x is equal to secant x.